Yes, ma'am.
Awesome. Okay. So for the first one from yesterday, we were dealing with geometric mean. And what we want to look for, and the way that I like to look at this is that there are technically two cases. Okay. So first of all, we have, there's Evelyn. So we again have an altitude being dropped from the right angle. So whenever we have that, we're going to have these two cases that are going to occur. So case one is when we're going to deal with the altitude as a geometric mean. And I'm going to abbreviate that to just GM, okay? Hi, Fatima and Evelyn. Evelyn, I know you're mine, but Fatima, if you would please in the chat, just drop in which teacher you have, okay? That way I can make sure your teachers know that you were here. I hope y'all had a great afternoon. All right, so one of the things I like to do when we're looking at the geometric mean is I like to go ahead and identify what am I looking at. So again, we have, here's my right angle. And so that tells me that this entire side here is our whole hypotenuse. Thank you. Okay, so our whole hypotenuse, and of course they've given us, thank you, Evelyn. They've given us the parts. And so what we're gonna need to do is 7 plus 9 is gonna equal 16. So that's our whole hypotenuse, okay? We're also going to go ahead and label. So our X, or our altitude here, is just that. It's an altitude. There we go. I might be able to write an altitude. When that altitude is drawn from the right angle down, it divides our hypotenuse into proportional parts. Okay, so this is like going to be, everything is so big and I need it to be smaller. There we go. So we're going to call them parts. Yes, thank you. All right, so we'll call 7 part 1, and we're going to call the 9 part 2. And we also want to recognize that we have 2 legs being formed here as well. And again, for some reason, my font is very big today. We want that to be a little bit smaller. Why is it being that way? There we go. Technology. Okay, so there's our leg. You're fine, Jasmine. How are you? Just like you already said, please post your teacher's name so that I can make sure they know that you were here today. Okay. All right, so once we have labeled everything, we kind of have an idea of what we're dealing with. We, again, can go back to what our cases are. And again, we have 2 essential cases that we want to focus on. The first one is going to be the case with the altitude being our geometric mean. And so therefore, when I say that it's going to be my geometric mean, then that tells me that it's going to be in a double position. So when we're thinking about a proportion, we have 4 spots. We have 2 extremes and 2 means. And our altitude in this case is going to be in 2 of them. So again, that's going to be altitude, and I'm abbreviating, and then altitude. And again, so they're in our 2 spots. And since it's our altitude, it's going to be to part. So we're going to have part 1 and our part 2. So now using our numbers, we can apply what we have in our image to our problem. So our altitude was X. And again, he's holding our double position. And then we are also going to put our parts, which would be part 1 and part 2, which is 7 and 9. Thank y'all. All right, so now what we can do is we can actually solve for X. And we do this with cross multiplication. And so we're going to cross multiply. And again, I ended up with a really fat font here. All right, there we go. All right, so 7 times 9, and of course our X times X. So therefore we have X squared equal to 63. To solve for a square root, we need to actually go ahead and do, or for a square, we're going to undo it by doing a square root. Okay, so we're going to take the square root, and that's going to be, get out our handy dandy calculators because we're not going to do that in our head right now. Oops, it helps to type it in correctly. There we go. All right, so we get 7.937, and it carries on and on forever and ever because it's a very ugly number. But they wanted us to round to the 100th, so that's going to be 7.94. Awesome. All right, so that is the case for our altitude. All right, so that was one of the cases, and that allows us to solve for that altitude that was dropped from the top. So now let's go ahead and look at our other case, and our other case is going to allow us to solve for our legs, and that's going to be our case 2, and that's what I refer to it as. Some people teach it as 2 different things. I kind of keep them all together. So case 2 is where the leg is the geometric mean. Okay, so for this one though, we do have 2 of them, and we're going to need to take that into consideration. Okay, so when we look at this particular problem, we have, again, we have the leg that's the y, and we have the leg that's the z. So that's why there's going to be 2. Okay, so for our first one, let's go ahead and we'll do leg y, and he is going to be in alignment with our part 1, and you'll see how that works. So again, if we're going to set this up, we would have our leg is going to be in our geometric mean position, and then it's going to be to our part, whichever's closest, that's part that's closest to our whole hypotenuse. Okay, so for both of them, that's going to be the case. So setting up for our first one, which is the y, we're going to have, let's see, let me move it just a little bit so we have a little more room. There we go. All right, so our leg is again y, and he is going to go into our duplicated position. Part 1, which was closest to my y, is the value of 7. And then, of course, our whole hypotenuse is 16. Okay, so we're again now going to cross multiply. And that's going to give us y squared equal to a very big number that I'm not going to try and do in my head. So
112.
What was it?
112.
Oh, 112. Thank you. Yeah, so I was like, I'm not about to try and do some of that stuff in my head, right? Not when we have a calculator. That's what they're for. All right, so now we're going to take the square root, and that one would give us
1053.
So 1053.
10.53.
Okay.
My bad is 58. 58.
Yeah, 58. That's fine. Yeah, 1058. You're good. All right. So that was again doing the y. So now, the thing that is about the cases is that now we can apply that same property, the leg over leg and all that, to do the other leg. And we can solve for the third side of this triangle. All right, so for that one, go back to my blues. This time we're going to, again, do our leg, and he's going to be in part to the 9. All right, so we're again going to go leg, which this time is z. And our part was the 9, because it's the closest part to z, and the whole thing, which is 16. All right, so this time 9 times 16 is like 2,600, I think, if I remember right. No, 144. Ha! I'm getting ahead of myself. So again, we end up with z squared equal to 144. At least this one's pretty.
It's 12.
Yeah. At least this one was pretty, because sometimes they're really not pretty, are they? All right, so it comes out to be 12. All right. So how is that? Is that a little bit clearer on the on just doing the geometric mean type stuff?
Yeah.
All right.
You explain it better than Mr. Judd.
Well, we all kind of team up together, but sometimes we just have to hear it from a different person or from a different direction. So that's why we kind of try to change up the, you know, the teachers and tutorials and stuff. So, all right. So y'all ready to try and tackle some of the 45s and 3060s?
Yes.
All right, y'all are ready. Cool. All right, so looking at this one, this is number 2 on yesterday's learning check, and the ones for today, they're again kind of almost identical to the same type of process. You're just going to have to kind of think out of the box a little bit and, you know, just kind of take it in steps. All right, so for these, we need to always recognize that when we're coming down to dealing with our special right triangles, they're always going to give us enough information to know, do I have a 45-45 isosceles right triangle, or do I have a 30-60-90? They're always going to give us enough information so we can determine that. Either we've got an isosceles triangle or something. There's going to be enough information to always be able to verify it. Okay, so for this one, we actually have 2 45-45 right triangles. Also, thing to remember about a 45-45 is that in order for it to be a 45-45-90, it also has to be isosceles, which means that we have 2 sides that are equal. Okay, and that's always going to be the case for an isosceles triangle. At least 2 sides are going to be congruent. So that's where our ratios come from. Our ratios, of course, we proved them last week dealing with Pythagorean theorem. If you do Pythagorean theorem on any of these, you're going to end up with this exact ratio. The ratios are always going to be 1 to 1 square root of 2. Okay, so that's just a proven theorem. We also use the formulas, and the formulas for these are the 1h, and h square root 2. Now, I like to stack them, and I'll be kind of honest with you, and Evelyn here, and someone could probably back you up on this, is that I'm kind of lazy and I don't really feel like drawing another triangle. Mr. Judd, I know, likes to draw a similar triangle that would match up with it, and there's the 90, and that would be the 1h, and h square root 2. But again, like I said, I just honestly get tired of drawing triangles all day long because I draw a lot of triangles all day long. So what we want to do is for this one, first of all, identify what they have given us. And they have given us the 7. Okay, the 7 happens to also be on this lower triangle. And so that's the one we're going to focus on first. All right, so that kind of hid that. So that's 7. Again, remember, this is an isosceles right triangle. So if this angle is 45, then this angle over here is 45. That means that these 2 sides are equal to each other. So if this side is 7, then this other side is also 7. Okay, so that's just kind of like the quick and easy on that. What that also tells me is that my legs, and of course when we're listing all these ratios out, what we want to recognize is that this is going to be the leg, a leg to the hypotenuse. And again, for our little triangle here, they are giving us the leg. Okay, and of course, if you're matching it up with a similar triangle, that means it's lining up with our side that's the leg. Okay, so that is 7. So if h is 7, then my other h is also 7. And then that allows us to just understand, okay, well, if h is 7 and my hypotenuse, which is my y value, equals h square root 2, then that means I just have to take my h and plug it in. And I get 7 square root 2. Okay. Now, my suggestion for these problems is to kind of leave it in the ugly format until we're ready to plug it into the calculator and get the answer. Because on a lot of these, trying to kind of carry around a bunch of decimals can cause more problems and more headaches than anything. So actually going through and leaving it ugly is probably going to be better in the long run. And I'll show you why. Because of course, right now we haven't, all we've done is gotten our y value here. And so that hasn't solved our full complete problem. Now, if you are ready to put that into Schoology, you can. And of course, 7 square root 2 is going to be 9.9. And I think that was, we did round these were to the 10th. Yes, these were to the 10th. So if you're in Schoology, you can go ahead and put in the 9.9 for that particular answer for y. But let's go ahead and again, like I said, as I carry on, I'm going to keep my ugly format. And I'm also going to erase what I have on my picture here so that I can apply it to my next problem. So now we are ready to go ahead and solve for our other parts of the triangle. And of course, this time we know that y was 7 square root 2. Okay, so we discovered that by solving our previous problem. Again, we're still using the same set of ratios. So our ratios are all the same, and I'll go ahead and list them off again. So it's 45, 45, 90, 1, 1, square root 2. And of course, we know that that's also the leg, the hypotenuse. And using the formulas, that's 1h, and h square root 2. All right, so again, all I did was just list off the formulas again. All right, so now looking at our blue triangle, what we can see is that x is going to be my hypotenuse, and that aligns with our h square root 2, which is what we're looking for. We also have our side measurement, so this time our legs were 7 square root 2. And of course, again, if it's an isosceles triangle, that side is 7 square root 2, and this one is also 7 square root 2. Okay, so that gives us 2 of those answers straight out. All right, so now again, ready to solve for x. And we know that x is equal to the h square root 2. We also discovered that h in this situation is 7 square root 2. So we're ready to just plug it in. Okay. Now, a few tricks, not really tricks, just things to know about the calculators. When you plug these in, my suggestion is always use lots of parentheses and make sure you're out of the square root. All right. So 7 square root 2 times square root 2. And again, I'm not playing when I say make sure you're keeping all that stuff separated, because sometimes in the calculator, especially our TIs, or if you're using Wabbit, EMU, or whatever apps you might be using, just make sure that it has separated out the radicals, because otherwise you'll get some weird answers. All right. But this one's actually not too bad. When we're multiplying, we multiply outside, so that's 7 times 1, which is 7. Square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So we actually end up with 7 times 2, which equals 14. And that's x. All right, so did I blow anybody's minds here? Or are we all good? All right, so that's just kind of the roundabout way. And again, I find it easier to kind of just, you can always plug it into the calculator later and get your answers, you know, once it's all said and done. All right. So if we're all good on that, we can move on, but I don't want to move too fast if y'all are still getting this written down. All right. If y'all are ready, we can move on to the next question. All right, what you got a question for? Or what do you have a question on, I should say?
How do you get the 7 square root of 2?
Okay, so the 7 square root of 2 came from here. All right. So let's see. Let me actually do this real quick. I'm going to move my screen real quick. So if we kind of back up a little bit, and let's just kind of talk about the 45-45 right triangle real quick. All right. Of course, I might not be able to draw it, but I'm going to try my best here. All right. So in a 45-45 right triangle, we know that each of these sides are congruent because, again, if my angles are congruent, then my sides are congruent. And of course, if my sides are congruent, my angles are congruent. Okay. So let's say this is 1 and this is 1. And I want to find my hypotenuse. Okay. Let's use Pythagorean theorem. So we're just going to go ahead and set up, a squared plus b squared is going to equal c squared. And that's going to be 1 squared plus 1 squared equals x squared. All right, and 1 squared is 1. 1 squared is 1. And so I get 2. We still need to take the square root. So when we're left, we find that our third side, our hypotenuse, x, is the square root of 2. Okay, so that's like proving our ratios. So now on our problem where we had below, I'm going to zoom out real quick and look at it. Whoops, not that, just move the screen. So in our original question down here, our triangle, so I'm going to look at this triangle that's right here, this small one right here. Okay, so if I recognize that it's an isosceles right triangle, so 45, 45, 90, but our side measurement was 7. So we should be able to recognize pretty quickly, well, if it's isosceles, then that side's 7 and this side is 7. Okay, so both are 7. So then we can go through and do the Pythagorean theorem. Which would be 7 squared plus 7 squared equal to c squared. And when you add that all up, we get 7 squared is, of course, 49. That's 49. And that is going to be 98. Now, for like my honors kids, we always break it down and we reduce the radicals. This would actually be the same thing as 2 times 49. And I would have them actually reduce the radical. If we kind of go back to our sample over here, I'm going to get the decimal value of square root of 2. And the decimal value of the square root of 2 is 1.41143562. Some big obnoxious. See you later, Evelyn. Thanks for joining us. All right, so that's the value of the square root of 2. Okay, so now what I want you to notice is what's going to happen here when we go and we take the square root of this value. And of course, what I'm doing here is taking the square root of my factors as well. And the square root of 49 is 7, and the square root of 2 is ugly. But anyway, let's go ahead and just do the decimals. So the square root of 98 is 9.8994, some big obnoxious number. Okay, so that's the square root of 98. Now, what I want you to see is that I just told you that if I was going to simplify it, that we would have 7 square root of 2. And if I take 7 and I multiply it by the square root of 2, that actually comes out to also being 9.89949. Okay, so the relationship to the sides and the hypotenuse is always the side measurement times the square root of 2. Okay, and if you took the 9.89949 and divided it by 7, you would actually get the same thing over here, 1.4142. And of course, all of that I'm doing just in the calculator. Okay, so that is just validating that the theorem, the Pythagorean theorem, and our special right triangles have that ratio. Okay, now that's the big complicated story on why or how we get the 7 square root 2. Okay, so kind of going back to our previous problem. So again, like I said, now that was doing it by Pythagorean theorem. Okay, and as you can see, if you are not real familiar with breaking down and simplifying radicals, seeing that 7 square root 2 would have probably been a little bit difficult. All right. But what we've done here is just gone through the long way of solving for this triangle. Okay. So by using these ratios, the 1 square root 2, to solve for the missing sides, we're actually making ourselves have less work by doing that. Did that help a little bit on where that came from?
Yes, ma'am.
Okay, because that's kind of like the real long way. It's like doing it by Pythagorean theorem's really long, where when we could just plug it into those ratios. Okay, and the reason I write out the ratios with the 1 square root 2 is because that's my pre-AP kids sometimes like those better. So it's kind of it just depends on how people want to approach the problems. All right, so let's just kind of go ahead and try we have a 3060, but if you'd like real quick, let me erase this real quickly. Let me kind of prove where these particular, I just need it to move. There we go. All right. So if you have an isosceles right triangle, or not an isosceles right triangle, you can't have an, let's say an equilateral triangle. All right, so if I have an equilateral triangle, what we should remember is that all 3 sides are equal, which also means that all of my angles are equal, okay, because they're all 60, so 180 divided by 3 is 60. If I drop an altitude from my top of my isosceles triangle down, we end up with a really kind of cool relationship. So what we're going to say is, let's say each one of the sides of my equilateral triangle is 2. When I drop this altitude down, that is going to split my triangle in half. Okay, so that means that this side here is no longer 2, but is now 1. I have a 90 degrees angle here. We have this angle is still 60 degrees. He hasn't changed. And if we do 180 minus 90 minus 60, we're left with 30. So that's 30. So if I want to find my height of my triangle, let's go through. We have, again, if I separate out this triangle, and there's height My hypotenuse is 2, and this leg down here is 1. And I can use Pythagorean theorem to solve. So I'd have 1 squared plus my height squared equal to 2 squared, which is my hypotenuse. All right, so 1 squared is 1. 2 squared is 4. We'll subtract 1. So we get h squared equals 3. And again, we're going to take the square root. So we find that our height is the square root of 3. So for our 30, 60, 90 triangle, no matter what sizes or how long our sides are, this relationship is going to be true for any 30, 60, 90 triangle. Okay, so there's our ratios. So for this one, I'm going to line them up 30, 60, 90, where 30 is going to be my short side, because that's here. It's opposite my 30. 60 is going to be my long side, and 90 is going to be my hypotenuse. And those relationships are going to be 1, square root 3, and 2. Those are the ratios. Now we have also been doing the formulas, and the formulas are very similar to the previous problem. This time it's going to be 1, and I think Mr. Judd was using a K. At least that's what I was using because Mr. Judd used a K. Then K times the square root of 3, and then 2 times K. And again, kind of remember, if we go back to our original back here where I was doing this problem, there's my 1. Whoops. There's my 1. My hypotenuse was 2 times the length of my shortest side. And my hypotenuse is the square root of 3. Okay. So let's go ahead and look at the last problem on today's, or I guess it was yesterday's actually. It was yesterday's learning check. Okay. So again, I have my ratios up here because again, both of the triangles that I have are both 30, 60, 90 triangles. So we're going to kind of roll with that. All right, and if it helps, I can actually break these up into 2 triangles. Let me change my colors here. All right, so we have this top one, and we'll just draw him out. That's 60. And that's 8, and we need y. All right, so there's my y. Okay, so we'll come back to find x here in just a moment, okay, because y is just going to be y. So basically all I did was just take my little triangle and I moved them over there. All right, just to kind of unclutter the field. All right, since it's a 60 degrees, that tells me that this one is automatically going to be 30 because 180 minus 90 minus 60 is 30. And that tells me we're using those ratios, so 30, 60, 90. And again, keep in mind, 30 is always opposite the short side. 60 is always opposite the long side. And 90 is always going to be my hypotenuse. All right, so in this case, they're giving us our hypotenuse. Our ratios, and so I'm just going to rewrite our ratios from up here. Square root 3, 2, and that's 1k, k square root 3, and 2k. So again, they're all lined up. Okay, so the short, it's opposite 30. He has the value of 1 times whatever. Long is k square root 3, hypotenuse 2k. All right. So we're given our hypotenuse. So that means that he's going to go here. Okay. So therefore, now we can solve for k. So we can take that. Let's see, we have 2k equals 8. Divide by 2. So we find that k equals 4. Well, that's this k. So k equals 4. So my shortest side of my triangle is 4. Now, why we like to tell y'all to go back to k, always go back to the leg, is because once you find that leg, everything else is really easy. All right, so all we have to do now is take what we have here for k and plug it in to our next one. All right, so our long side, which happens to be y, is equal to the k square root 3. Well, we now know that k is 4. So 4 square root 3. And that goes here, 4 square root 3. And again, that's this side here, 4 square root 3. Now, get that decimal value. I have no clue. We got to type that sucker in. Okay, so we get 4 square root 3. So that has a decimal value of 6.93. And I think on this one, we wanted just the tenths, so 6.9. All right, so that's the decimal value. Now, again, as I go through this problem, I prefer to keep it in the square root format, okay? And that's just because, yeah, it's less work. I don't know, it's just less work to just keep it that way than to have to go over and type it in. But it really doesn't matter, other than sometimes round off arrows can sometimes scream at us. All right, so if we're all good with that, does everybody see where we got the 4 square root 3?
Yes.
We are all good. Okay, so now what we want to do is we've got to take that information, and now we're going to move down to the other triangle. All right, so now we're going to look at this triangle, and I will transpose him. And of course, our 90 degrees here, 60 here. There's my x. And we have to remember that now for y, we've already found him. He is 4 square root 3. Okay. So now it gets fun. Not really. It's pretty easy. All right, so watch how this is going to work. So we want the hypotenuse, right? 4 square root 3 happens to also be the short side of this triangle. Here's my hypotenuse, and this long part is our long side. Okay, so keeping up with our pattern so far, we have a 30, 60, 90, 1, square root 3, and 2 are our ratios, and those are always going to be on the formula chart. So that's part of the reason I write them out, even though we can just go straight to the formulas. But I just write them out because, again, they're on, that's usually how they present it on a formula chart, and they're almost always on a formula chart. They're somewhere out there in a formula chart. So that's part of the reason I just go ahead and write them all the way out. All right, so our formula is taking that ratio 1 times k times the square root of 3, and then 2. Okay, so you'll notice that our ratio is just basic, our formula is basically just the ratio with the variable stuck next to it. So it's all the same thing. All right, but again, they gave us, or we found in our previous problem, the short leg. So our short leg is 4 square root 3. Okay, and you can actually write that out. We now know k is equal to 4 square root 3. Okay, so that's kind of where that's falling into it. All right. So now all we have to do is take it and plug it into each of the formulas, and we can solve for any other part of our triangle. Okay. So if I need it now, of course, for this one, we just needed the long side, the hypotenuse, but if I wanted the long side, again, my long side here is k square root 3. Well, we already know that k is 4 square root 3. And this is, again, where in your calculator, be very careful, use parentheses, make sure it's all broken up. You're literally just spitting it right back out. 4 square root of 3 times the square root of 3. Get your calculator, and you're going to get 12. To find our hypotenuse, again, it's 2 times k. Again, k is 4 square root 3. So that's going to be 2 times 4 square root 3, which is 8 square root 3. And of course, we can just plug that into the calculator and get our decimal values, especially since that's what Schoology wants us to do, right? And we get 13.9. And that should be your x value. So there's your y and there's your x. Okay. Let me get some water real quick. Okay. All right. So everybody's doing good?
Yes, ma'am.
Yes, ma'am.
Awesome. All right. So are y'all wanting to look at today's learning check?
Yes, please.
Okay, let me grab those real quick. I guess that's one of the nice things that we're all doing the same thing. Now you might find tomorrow when we start trigonometry that you might find that that's going to be a little bit better. You might actually decide that just using trig is so much easier than trying to go through remembering all of this. So we're hoping that you will like the trigonometry a little better. I know that seems like it could be a little bit intimidating, but I promise you it's not that bad. All right, so that's the first one. I have to remember that we're doing the different square roots. Okay, all right, so now, same process, but the only thing is that we did not put that second step. So like in the ones from yesterday, when we were putting those in there, we kind of put those y values in there. And of course, the idea was trying to guide you to, okay, I need to find this. And then once I find this, I can take it to find that. So we kind of dropped that off this time, but it's still the same exact principle. Okay. So, and of course the numbers are a little bit ugly, but that's okay. We can handle it. We've got calculators. That's what calculators are for. Desmos is awesome. Okay. And I think y'all use lots of different other ones when y'all are at home. I've heard everything from Mathway to Photomath to you name it. I know everybody's got their own calculator they prefer to use. Okay. So for this one, again, we should note we've got 2 45-45 right triangles. And again, we're wanting to go from one to get to the other. So this is just like the last two we just wrapped up with. And so we have this triangle that we have been given enough information on. So we have the hypotenuse being given on that one. All right, so let's draw it out. I think maybe drawing it out, getting it separated from the other one has been a little bit helpful. All right, so it's 45-45, and that is 9 square root 6. Okay, so again, we want to remember that with a 45-45-90, that we are dealing with an isosceles right triangle. So if these two angles are equal, then these two sides are equal. Now, the thing is, they gave us our hypotenuse. So now it gets to be fun, right? It is fun. It's actually not bad. All right. So 45, 45, 90. And our ratios are 1, 1, square root 2. And that is 1h, 1h, and h square root 2. All right. And again, they gave us our hypotenuse. So we want to remember that these are always going to be the leg, and then hypotenuse. And that's what they gave us here. So that's going to go here. So again, there's all my hypotenuse info. So even though it's given it to us in a very ugly format, it's okay. We can still go with it and flow with it. Okay. And we just set it equal. So we have, it helps to have a stylus pen here. Okay, so h square root 2 equals 9 square root 6. All right. Divide by the square root of 2. Now remember, square root of 2 is a number. It's an ugly number. It's very irrational. Irrational means it's really crazy. It's way out there. Okay, and it is because it's got all those decimals. So we're going to go ahead and just divide by the square root of 2. And to simplify it, it's actually 9. So we can divide what's inside, and that would be like basically saying 6 divided by 2. And that is going to give us 9 square root 3. But that's also going to give us a decimal. And I know I was talking to my students and reminding y'all that we are very aware currently that COVID hit right about the time y'all would have been learning this last year. Okay, so we know that for some of this, it's like, whoa, first time we've ever seen it. And that's, we get you. We really do. We understand. Okay. All right, so that's going to be approximately 11.0227. And I'm going to hold on to the decimals because, again, that's just the way that it's going to be easier. All right, so did everybody follow? Again, all I did. Now, one of the things I will give you a little tidbit on Get More Math. If they are asking for the exact value, you would have entered in for this one just the 9 square root 6 divided by the square root of 2. Okay, so if it's Get More Math and they're asking for that exact answer, just type it in just like that. Just plug it straight in and it'll check mark it off. It'll be okay. All right, that's just kind of like a little bit of tidbit. Don't let the Get More Math be intimidating on that regard. It's just roll with it, just stick it in there, it accepts it. I guess it must have its own calculator and it can figure it out.
For the answer, I got 15.58.
For which one?
For the answer for 9 square root of 3.
Let's see, so you did 9 square root 6. I'm not sure, how did you get 58? Or let me see. I'm not sure how you, so what did you get again?
Because I had did 9 to square root of 3, because 6 divided by 2 was 3.
Oh, okay, so you got it into, actually, I'm not really sure what you got there. So how did you, I wish that there was a way you could show me how you got it.
When I did 9
Yes.
times the square root of 3, I got 15.59 or 15.58845727. But I rounded it to 58.59.
Okay, what calculator are you using?
I'm using a TI 83 plus.
Really? I'm wondering why. I'm just trying to figure out why we're all getting kind of different answers. This is kind of interesting. So 9 square root 3. Yeah, that's what it should have been. Okay, hang on. Let me do this again. You're right, 15.59. Okay, I'm with y'all now. I think they're, let's see. I can't scroll back up. I can't scroll up to go see what I did wrong. Nope. Okay, y'all are right. I don't know what I did. Y'all are very right. Thank y'all very much for stepping up. Y'all are, that's awesome. Nope, y'all were correct. Okay, woo, saved. Thank you. It's wonderful when you type stuff in. Be very, and again, like I said, be very careful when you type this stuff in, because like, there you go. I don't even know what I typed in, but it definitely was not coming out correct. So there you go. Be very careful on that. All right, so now we're all on the same page and we're good.
Yes, ma'am.
All right, thank y'all. Sorry about that. Okay, well, now that we got it straight, and we're at 9 square root 3. Okay, so with that one I can handle. Okay, so that actually tells us that each of the legs, and now we can take it over to the other one. All right, so let's get the other triangle drawn. And I can't draw it sideways. So this time, again, that was the 9 square root 3. That's another reason why I like exact values, because I'm less likely to mess that up. But anyway, that's beside the point. All right, so again, we have a 45, 45, and we're looking for the side value. So again, set it up. And of course, they gave us the hypotenuse, or we found the hypotenuse by doing the previous problem. All right, so 45, 45, and 90. And that is 1H, 1H, and H square root 2. I guess we're going to see if Miss Clark can do this without messing up. All right, so again, 9 square root 3. And this is one of those where, again, I find that I'm grateful that Get More Math will kind of just let it roll. That's about how that goes. Okay, so H square root 2. It's going to equal 9 square root 3. And we just need H. I'm almost about ready to say, let y'all have that. And let's see if Miss Clark can catch up with y'all, because y'all are plugging it in more accurately than me. So we're dividing by the square root of 2. That was my 1102. I knew the number looked right. Did y'all get 11.02?
Yes, ma'am. 11.0237.
Okay. Okay. So I wasn't wrong when I was thinking that I had an answer that was going to be that way. So, okay, I feel better now. All right, so 11.022. So 11 point, I think we were doing hundredths on these anyway, so you would have gone to 2 decimals. All right, yay. All right, so is that making more sense on the 45, 45?
Yes, ma'am.
Awesome. All right, y'all ready to do one more? We might be able to get it done before our time's up, but that's okay. We got it. Even if we go over just a little bit. I don't want to waste y'all's time either. And I can help y'all get set up on the next one. All right, so for this one, we are dealing with the 30, 60, 90. And again, we're kind of dealing with the same thing. We just want to separate out that triangle. This is 5. That's our 60, so that means our 30. And this is going to be our short side. And our short side is what we are looking for in this situation, because our short side is the hypotenuse to our small one. Okay, so that's kind of I guess, going to be kind of nice because this is the hypotenuse of the small one. And it's almost too small for me to write on. So we'll go ahead and just set this up. And it's 30, 60, 90. And that was 1 square root 3, 2. And that's 1k, k square root 3, and 2k. All right. And again, our hypotenuse was not given. The short side is not given. That would be our k. And our long side is given as, so that's going to be our k square root 3. And that is something else you can do is like, you know, even on the triangle that you have, you can actually just mark out, you know, okay, so that's my long side, and then solve for the short side. So that's another option if you can reckon, you know, if you want to just another shorter way to do it. All right, so when we solve for that, square root 3, we're divided by square root 3. And for time's sake, we are just going to leave it that way. And again, gratefully, our, what was the first one? For which one? Because I haven't solved anything
11.02.
yet.
The first question also is 11.02.
Okay, so Yaris, what was the first one this week? Oh, the first one was the 45. This one over here. It was 11.02. Okay. All right. Did that answer your question? All right, good. All right, so once we find K, it turns out that once we have that value, and I'm actually going to just leave it alone. I know y'all have calculators and you're getting the decimal value, so you're good to go. That actually happens to also be the hypotenuse of our other triangle. So we're going to kind of repeat the whole process again and go 30, 60, 90, and it's 1k, k square root 3, and then 2k. And again, it's our 5 square root 3 ends up being the hypotenuse for our other side. Okay, now this is going to look really ugly, and I know it's really messy because I was noticing the time, so I was kind of moving a little bit fast, which means that it's going to be really messy. But again, we end up with 2k equal to 5 over the square root of 3. And when we divide by 2, we end up with a fraction. And I know that, of course, y'all probably just typed it into the calculator, but when you're dividing by fractions, just remember it was keep it, change it, flip it, or keep it. Sometimes y'all would have same, change, flip. Might be one way that y'all would have learned it in grade school. So that would be k is 5 over 2 square root 3. Now, the reason I'm leaving it that way is because when I go to plug it into the next formula to take it, because that's k, I still need to take it to our next step, which is plugging it into our x value. So our x value is that k square root 3. And so we got to take all that ugly fraction and actually plug it into the formula. And what you're going to notice is the square root 3s are going to cancel out. So k is 5, 2 square root 3, and the square root 3. So anyway, they cancel out. Of course, you could have just typed it in the calculator and you would have gotten 2.5 anyway. So, all right. Is that what y'all got? That would be interesting. Let me try that. 5 divided by, oh wait, I got to do it the other way. I got 2.5. No, square root 3 should cancel out. That one was kind of ugly with lots of decimals floating around in it. So it should be 2.5 because the square root 3 is over 1, and so those are going to actually cancel, leaving us 5/2. But that's the only reason why I kind of like leaving them with the radicals, kind of like that. Then that way, when I end up with something like that, I can see where it cancels out, and it's really less than trying to hang around with all the decimals. So, are y'all good?
Yes, ma'am.
All right, y'all want me to? Okay, do y'all want me to set y'all up on the next one? And okay, now the next one are actually, it'll take us 5 minutes to work through the next problem. We'll go ahead and just do it real quick. All right, so this one goes back to being a geometric mean. And for this one, again, they gave us, of course, our altitude is here, but that's not what we're looking for, and we're not being given any information, so we'll move to the next case. So we are given the leg and our parts and our hole. Okay, so for this particular setup, we're going to want to use the case where it's the leg is our geometric mean. And it's going to be the part to the whole hypotenuse. And again, on this one, we end up with all these radicals. Just carry them on through, and then when you get to the calculator, it'll be out. It'll be fine. All right, so 7 square root 33 is going to be our geometric mean. So he's in our duplicated position. Our closest part is that 33. And the whole length is what we're looking for. So we're going to cross multiply. And again, just put it in parentheses and let the calculator handle it. It's actually going to be 49 times 33. And then divide by 33. And you should get x equals 49. That work?